This problem concerns flexible budgeting, and it's comprised of about 9 different parts, and each part is based on the original data that you're given up here at the beginning of the problem. So the problem is about a protein supplement company, and they're making cartons of protein powder. So the first one we're going to do is calculate the standard predetermined variable manufacturing rate. So the first thing we want to do is look at our formula. So that's equal to your static budget variable overhead divided by the quantity of the allocation base. So here the variable overhead, the static budget is 60,000, and the allocation base, you are told that your protein allocates manufacturing overhead based on direct labor hours. So the base is direct labor hours. That's 12,000 hours. So the variable overhead rate for manufacturing overhead is $5. So the next one we want to do is what is your fixed manufacturing overhead rate. So here you want to take your fixed cost, your static budget for your fixed cost, which is $48,000. So we'll enter that in here. And of course the allocation base remains the same at 12,000 hours. So that gives you a rate of $4. So the total manufacturing overhead rate is $9, your 5 plus your 4. So the next one we're going to look at is calculating what is the standard cost per unit of input, looking at your materials, your labor, your variable overhead, and your fixed overhead. So what we want to do is calculate the cost to produce 1 carton of your protein powder. So the first thing we're going to do is take the information that we have been given in the problem. So this is the standard data. This is the dollar amounts and the quantities that should be used to produce 100,000 cartons. So when we go down here now, we're going to be looking at our direct materials. So we are told that the quantity is 2 kilograms per unit, and we're told that the price of that should be $1. The direct labor, you are told that it is 0.25, so 1/4 of an hour per carton. So we'll put our 0.25 here, and the labor rate is $12, and that's from up here, it's $12 right here. So we'll put our $12 in right here, and we want to make sure this actually rounds up to our 0.25. Our variable manufacturing overhead, again, that is allocated based on direct labor hours. So the allocation base here is 0.25, and we know that the price is $5 because we've just calculated that. And again, for fixed overhead, also calculated based on direct labor hours, which should be 0.25 for each carton. So this total standard cost per carton should be $7.25. So that's how much it should cost to make it. So now throughout the rest of the problem, we are going to be looking at how our actual quantities and our actual prices differ from what we had expected. So all of these figures here are the expected or the budgeted standard amount. So this is the quantities you should have used, and these are the prices you should be paying. But of course, in reality, what happens is Sometimes you end up using more materials, sometimes there could be an increase in the price of materials. Maybe it's going to take you longer to make something than you had thought, and so on. So we're going to be looking at variances in each of these 4 categories. So it might seem quite detailed, but in actual fact, we're just looking at these 4 categories and figuring out were we using more or less than we had thought, and were we paying more or less than we had planned. So we'll start off with our direct materials price variance. So when we look at that, look at your formula. So you're comparing the actual price to the standard price, and we're multiplying that by the actual quantity used. So we need to do a little calculation first. We need to figure out what was the actual quantity used. So although our budget was developed based on an assumption that we would be producing 100,000 cartons, in actual fact, we didn't produce that much. We produced 80,000. So in this next section here, what we're trying to do here is figure out for 80,000 units or 80,000 cartons, how much material did we actually use. So we made 80,000 units, and we're told we used 2.5 kilograms. So the 2.5 is coming from right here. So this is the actual. So the actual amount used is 2.5, but we see here, of course, that we had expected to use only 2 kilograms. So we know right away there's going to be a bit of a problem there. So now what we want to do here, we want to look at the actual price per input unit, and we go up here to our actuals. So the actual price per kilogram for the materials was $1.50. However, we had thought we would only be paying $1. So you can see right away that we have a variance here. So we'll enter in the price that we actually paid versus what we had thought we would pay, and that is going to be multiplied by the actual quantity, which will give us $100,000 unfavorable variance, because the price you paid per unit is higher than you had planned or that you had factored into your standard costing. So that's the price variance. Now we want to look at what are the implications, what are the costs associated with using more materials per carton than we had planned, because we know from up here we had planned, or the standard data would tell us that it would be 2 kilograms per carton, but in fact we actually used 2.5. So that's what we're doing. When we talk about efficiency, we're looking at, did we use more material than we had planned under our standard budgeted information. So we're going to look at the efficiency. So the first thing we're going to do here is we're going to calculate what we should have paid. So the standard input, so we know we made 80,000 units, and what we should have used per unit was 2 kilograms per unit. And the next thing that we want to do here is we want to look at what is the actual quantity of input allowed. So here we use 200,000, so we know we use 200,000 kilograms of direct material. We've just calculated that. So it's 80,000 units, and we're told we use 2.5 kilograms of material. So we'll take our 200,000, we don't need to recalculate, we've already done it. Then what we want to do here is subtract from that what the standard quantity allowed. So for 80,000 units, you should have only used 2 kilograms per unit, or a total of 160,000. So we'll subtract 160,000 from our 200,000, and that will give us $40,000 unfavorable variance. So what that means is we used $40,000 worth more material than we should have used for that level of output. So our total variance in terms of our price variance was 100,000, and our efficiency variance 40,000. We'll enter that in here. So our total variance for direct materials, so our total direct materials cost us 140,000 more than it should have. And that's comprised of a price increase, which counted for the 100,000, a price increase in the price of your direct materials, and the other factor here was you used more direct materials than you should have for that level of output. So that's your 140,000. Okay, so the next thing we're going to look at is our direct labor. So, as you will recall from the information you were given, we know what we should have spent on direct labor. So the first thing we want to do is we want to find out how much labor, how many hours should we have used given that we produced 80,000 units. So it's 80,000, and we know we were given the information that it should take 1/4 of an hour, 0.25 per unit. So we should have used 20,000 hours to make our 80,000 units. But of course, things don't always work out the way they're supposed to. So in terms of the our actual quantity of input was 40,000, which we've already calculated, and our the number of hours we should have spent. Sorry, this shouldn't be dollars here. Okay, this is section 5 of this multi-section problem. So with section 5, what we are looking at here is to calculate the impact of the difference in the actual cost of labor per hour versus the standard or budgeted expected cost. So we know that the labor cost, and we're given this up here in the information you're given, the actual wage rate was $15, whereas we'd been planning on only $12. So that's what we're looking at, the impact of here. So we go down, we enter in you look at your formula, your actual price per unit minus your standard times the actual quantity of input. So we have our actual price, or our labor rate, and our standard labor rate, what we thought we would be paying, and what we want to do here is multiply that by the standard quantity of input allowed for the outputs we achieved. So we made 80,000 units, so how many hours should we have spent on that? So you were given up here in the information you should have basically what you had expected to spend was 1/4 of an hour, but you actually took a 1/2 an hour, 0.5. So what you actually used here was 0.5. So it took 40,000 hours. So what you actually spent here was 1/2 an hour, so that's 40,000 hours. So you're looking at the impact of an increase of $3 per hour, and you use 40,000 hours. So that's $120,000 unfavorable variance. So now the next thing we want to find out about labor is the impact of using more time per unit than we had actually planned to use. So the standard quantity allowed, so the number of direct labor hours allowed here in part 6 was, we know we made our 80,000 units and we should have spent a quarter of an hour on each one, so we should have spent 20,000 hours, but we know, we've just calculated up here, we actually use 40,000. So our actual is 40,000, we should have spent 20,000 hours, and we want to see what the impact of that is. And here we're only calculating the difference in the number of hours used. So we're going to multiply that by the standard price, not the actual price per hour. So that gives us an unfavorable variance of $120,000, 240,000, excuse me. So now we look at our total variance. So we spent $360,000 more on our labor costs than we had planned. So 120 of that was because the hourly wage rose from $12 to $15. And that could have happened, for example, when the standard price was set. It may have occurred before negotiations with the union, and perhaps after negotiations the wage rate went up from $12 to $15. And the efficiency talks about how much labor. So how many hours did you use more than you should have, and what was the cost of that? So it was 20,000 hours is what you used more than you should have. The impact of that was 240,000. So the total $360,000 more in labor cost than you had anticipated when your standard costs were developed. Okay, so now we have completed the variances on our materials and on our labor. So the next couple of sections, it's going to entail looking at the calculations on any variances related to overhead. So the first one we are going to look at here in part 7 is to look at our actual overhead. So you're given the actual overhead costs, so that's up here, your 60,000 in variable and 30 in fixed. So we'll just go ahead and enter those in down here in part 7. So we have $60,000 plus 30,000. So your actual overhead was 90,000. So now what we want to look at is how much were we expecting our overhead to be. So we know our overhead is allocated based on our direct labor hours. So for 80,000 units that we produced, and that should have taken a quarter of an hour per unit. So that should have been 20,000 hours. And the total overhead amount, remember we calculated $4 and $5 for fixed and variable for a total of 9. So you should have spent 20,000 hours making your 80,000 units, and the cost would have been 180,000. So now finally we have some good news. Our actual overhead came in at 90,000, and using our standard cost, our standard budgeted cost, we had been expecting 180,000. So you have $90,000 favorable variance. Finally, some good news. So now in part 8, what we are going to do here in parts 8 and 9, we're going to break down this 90,000 into the components so we get a better idea of what actually led to this favorable variance. So we know from the previous calculations here, our overhead, our actual cost is 60,000 plus 30,000, which is 90. So the next thing that we want to do is we want to figure out what the variable portion of our variance is comprised of. So we have our 80,000 units, and we know we were supposed to have spent a quarter of an hour per unit, and we know from our previous calculations the variable portion of our overhead was $5. So we should have spent $100,000 on our variable overhead. So our fixed was 48,000, and the variable is 100,000. So we have 148,000. So of our 90,000, 58,000 relates to the flexible part of our overhead budget variance. So the final section in this problem is, we'll just take this out for the moment. So the final section is to calculate the volume variance. So in part 9, what we are doing here is we are looking at our actual flexible budget, which we've just calculated, our 48,000, and our 100,000 from the previous part, so it's 148,000, and the standard amount of overhead that you should have allocated is 180 from part 7. So we'll put in our 180,000. So that leaves us with $32,000 of favorable variance. So now you can see 58 plus 32 equals our 90,000. So that's a breakdown of the overhead budget variance. So when you're looking at your overhead, it's important to be able to break down how much is due to various components. When you break things down, you always get better information.